So today we're going over quadratic equations, and basically quadratic equations are anything of the form where you have ax squared plus bx plus c, where a is not zero, because obviously if a was zero, then all we'd have is bx plus c, which would be a line, right? So we have to have the largest degree term be squared. That's basically what makes something a quadratic. And when you have a quadratic equation, it'll automatically graph to a parabola. The quadratic formula, and when you can use it, is whenever our quadratic is equal to 0. That's the only time it works, is when y equals 0. So for example, let's say I have a quadratic formula such as this. So here it's in the right form because we have a squared, and notice we couldn't solve it like this because we have to have it equal to 0. So we have to subtract 1 from both sides. Now it's equal to 0. And I can see if I'm always using ax squared plus bx plus c, that a is going to be 11, b is negative, and c is 1. Now all I do is just plug it in. So I have x. My x's are here. Let me say that better because we don't have any x's. So here we have n is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And we know what a, b, and c are. We just plug it in. So we have negative 9, which is positive 9, plus or minus the square root of negative 9 squared minus 4 times 11 times negative 1 divided by 2 times 11. So we have 9 plus or minus the square root of 81, and we have a negative times a negative, so it's going to be positive 44 divided by 22, which is going to equal 9 plus or minus the square root of 125 divided by 22. So, and really what we want to know is, if we take 125, then we really have to factor it. That's the easiest way if you don't know what to do. So I know that 125 is divisible by 5, right? Because it ends in 5. So I can say this is going to be 5, and it's 5 times 25. And 25 we can see is 5 times 5. What I'm really looking at is the square root of 5 to the 3rd power. If I have the square root of x squared, that's always going to be equal to x as long as x is greater than or equal to 0. If I have 3 5s, it's really the same as the square root of 5 squared times the square root of 5, and that's simplified, okay? So if I come down here, I have 9 plus or minus 5 times the square root of 5 over 22. And if, let me see what I can erase here. So this is really the same as 9 over 22 plus 5 times the square root of 5 over 22, or 9 over 22 minus 5 times the square root of 5 over 22. So that's basically the solution. And you can find that, which means that those are 2 solutions for n. Now I know what n equals, okay? And if I were to graph it, they would be the x-intercepts, because remember we set y equal to 0 here. Okay, so now we're going to do the same thing for this. But, most people really kind of hate working with fractions. I'm going to say if I don't have to, I'm not going to do it either, okay? So the easiest way to do this is actually going to be to multiply. If I multiply both sides by something, it's not going to change anything. So why can't I multiply both sides by 8? And I do that because that's my least common denominator. If I were to distribute now, 8 times 1/8 is going to be just 1. So I end up with x squared plus 8 times x is 8x minus, and then 8 times 5 halves. Basically, we're doing 8 times 5 halves. I can cancel the 8 and the 2 and get 4. So I get 20 equals 0, because 0 times 8 is still 0. And now this is a lot easier to use the quadratic formula on than fractions, isn't it? So here I have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And here we know that b is equal to 8. So I have negative 8 plus or minus the square root, and 8 squared is 64, minus 4. A is 1, so I don't need to worry about that. And C is negative 20. And that's divided by 2 times 1, because A is still 1. And then I just start simplifying. So I have negative 8 plus or minus the square root of 64 plus 80 over 2, which is equal to negative 8 plus or minus the square root of 144 over 2. And the square root of 144 is 12, because 12 times 12 is 144. So now I can say, okay, that means I have two solutions. I have negative 8 plus 12 over 2, which is going to equal 4 over 2, which is 2. Or I have negative 8 minus 12 over 2, which is negative 20 over 2, which is equal to negative 10. So if I want to know what my solutions are here, x is equal to 2 and negative 10. So I'm not going to do this unless you want me to, because it's really about the same, but let's just start it. I don't need to go through the whole quadratic formula, because I do think that you probably know how to do it. But can I use the quadratic formula on this the way it is?
No.
No, why?
Because you still have to distribute the x.
Right. So I need to have this be x squared plus 6x equals negative 30, right?
Mhm.
And then what can I do next? Can I use the quadratic formula now?
No, also, wouldn't that be 6x?
Oh, I'm sorry, 6x. You're right. Sorry about that. Yes. Can I use it now?
Yes.
So I can't. The
Oh,
reason
because it's not 0 on the other
because it's
side.
not equal to 0. Exactly. So I'm going to add 30 to both sides. I'm going to get x squared plus 6x plus 30 equals 0. And now I can use a quadratic formula on that.